Actually, you know what? There is one more. Sorry. There's something called Gauss-Jordan elimination. Gauss/Jordan. Because I guess another mathematician added on to what Gaussian had done. So, let's start.
I have a question. If you run assemblies good are they like changing the rail schedule?
Yeah, we get out at 8:58.
Okay. No, that was odd. Wait, was it supposed to be 9?
8:58.
So 8.
All right then, basics of a matrix. Start writing. A matrix is a rectangular array of numbers arranged into rows and columns. A matrix has rows and columns, and it's filled with numbers, no variables, just well, usually, I guess it could have variables. Mostly it's filled up with just numbers. For example, here's a matrix. It's enclosed within brackets. Measured this way or looking along this way, these are what are called rows. So horizontally are the rows. Vertically, these are the columns. A particular number inside of a matrix is what's called an entry. So this number right here, for example, that's an entry. How many entries are there in the matrix? 6. How many rows are there? 2. How many columns are there? 3. Okay. The size of a matrix, other textbooks call it the order of the matrix. Or the dimensions. Some textbooks refer to it as the dimension. The size of a matrix is described as the number of rows by the number of columns, and it always has to be done in that order. Always the number of rows and then the number of columns. It has to be described that way. So for this particular matrix that we're taking a look at, how many rows? How many columns? So you would call this a 2 by 3. That's how you describe it. This matrix right here, it's a 2 by 3 matrix. Yeah. Any questions so far?
Does it get harder?
Yeah. Yeah, it does. In terms of basics, that's probably all we need to know for the basics. Let's move on to an augmented. This is objective 2, an augmented matrix. An augmented matrix comes from a linear system of equations. For example, here's a linear system of equations. 2x minus 3y equals 9, and 3x plus 7y equals 10. That's what we dealt with back in chapter 10.1. Just a linear system of equations. Using the linear system of equations, you can form what's called the augmented matrix.
I have a question. If you have two equations, are they related?
And you use the coefficients of the variables and the constant after the equal signs to make the matrix. And it has to be in the same order. Row 1 is going to be equation 1. It's going to be a 2, and then a negative 3, and then a 9. That's row 1. Row 2 is going to be your second equation. 3, 7, and 10. This is what's referred to as an augmented matrix. The point of all this, the direction we're heading, is we've learned one way to solve a system of equations. We can use elimination method or substitution method. And that works pretty well with small systems like this where you have two equations, two variables. Most applications in the real world, computer programming, economics, have systems of equations that maybe have 7 or 8 variables, 7 or 8 equations. Those are extremely tedious to solve by hand. If you set up an augmented matrix and type these numbers into even one of these graphing calculators here, you could type numbers into here, hit one button, and it solves it in a matter of half a second. So in terms of computing power, matrices are much quicker, much easier to solve systems of equations than by hand. Okay? That's the point of learning about matrices. If you're going into any kind of engineering field or something relating to solving complicated systems of equations, you're going to want to learn how to use matrices because it makes it a lot easier.
So in other words, if you're planning on being smart in math,
matrices will make your life easier. Yeah. So your homework for 10.3? It starts off by giving you a system of equations, and they ask you to make an augmented matrix. Does anybody have any questions on how to do that? They may ask you also to go backwards. If you're given an augmented matrix, do you feel comfortable in forming the system of equations from which it came? Would that be pretty easy? Do we need to do more examples on this? Let's do example 1. Use the augmented matrix. To write a system of equations. So now we're going the other way. I'm going to give you the matrix already. From that matrix, write a system of equations. Yeah. That's a good thought. This one's, it's still an augmented matrix because it has one more column than it has rows. By the way, let's just practice. What's the dimension of this matrix right here, the one I'm circling? 3 by 4. 3 rows, 4 columns. What's the system of equations? Now, an equation comes from a row of the augmented matrix. If you look at this row, it has 4 entries. The last one has to be the constant after the equal sign. So we have 3 numbers that need to act as coefficients. If there's 3 coefficients, there's 3 variables. This is the coefficient of x, this is the coefficient of y, this is the coefficient of z. This is the number after the equal sign. So using the first row, what's the equation? All right. What's the equation from the middle row? Yeah, how do we deal with the 0? There's no y variable. I mean, you could put a 0y in there, but that doesn't mean anything. So 6x plus 3z is equal to 4. Bottom equation is x plus y plus 2z is equal to 8. Yep, that's all they want for this first objective is, or second objective is,
So what
to
if
feel
you have-
comfortable with an augmented matrix.
What if you have like 6 or 7? Do you use like all the letters?
You could come up with any letters for variables.
Okay.
Any questions on augmented matrices? All right then. Let's move on. Elementary row operations. You know what? We might have to